Okay, so we're going to start 7.8, which is factoring ax squared plus bx plus c. So you'll see this looks a lot like what you did in 7.7, but now you're going to have a coefficient on that first squared term, which makes things just a little trickier. So our learning goal for today is I will factor trinomials of the form ax squared plus bx plus c, and that's it. So let's get started. So our first example, we're factoring 3x squared minus 6x minus 24. And if you think back to previous lessons, remember I said you always want to try and see if there's a greatest common factor that you can factor out first. If there is, then you want to do that. Otherwise, this problem can get very complicated. So if I look at my coefficients and my constant, 3, 6, 24, those are all multiples of 3. Which means my greatest common factor here is 3. My greatest common factor doesn't have a variable because this guy is x squared, this guy's x. This one doesn't have a variable, so my greatest common factor is just going to be a constant, which is 3. When I factor that out, 3 times x squared gives me 3x squared. Then I need to keep the subtraction. 3 times 2x will give me that 6x. And 3 times 8 will give me that 24. So I just divided each of these terms by 3, pulled that out to the front, and this is what I was left with, 3 times x squared minus 2x minus 8. Now from here, I want to see, can I continue factoring or am I stuck? So the 3, obviously, I can't do anything with that, but let's just look at this like this was its own problem, x squared minus 2x minus 8. I want to factor this using the methods that I used in previous lessons, where I want two numbers that will multiply to give me this negative 8 and add to give me negative 2. So if you think about 8, we can get 8 from 1 and 8 or 2 and 4. And then I need to decide, because this is negative, these need to have opposites. So it either needs to be positive 1 and negative 8 or negative 1 and positive 8, right? We need opposite signs, so when they multiply, I get a negative. Because my middle term is also negative, that means the greater of these numbers has to be the negative term. So hopefully you're catching on to that. So that means this would have to be positive 1 and negative 8, or positive 2 and negative 4. Because in this case, when I add together, I'll get a negative middle term. So 1 and negative 8 is negative 7, so obviously that doesn't work. 2 and negative 4 make negative 2 together. So this is going to be the numbers that I'm using when I factor. The key here is to make sure that you keep that 3 out front. So don't forget about it, even though it doesn't have anything to do with the factoring of this piece. We don't want to forget it in our final answer. And then this will break into x plus 2 times x minus 4. So first I did greatest common factor, pulled that out, and then I factored this just according to the rules from 7.7. So now when I look at this, there's nothing else I can do to factor any further, so I'm done. So that was our first example. For example 2, I'm going to start in a similar way. I'm going to look and see if there's a greatest common factor that I can take out. I'm factoring 3x squared plus 7x plus 2. 3, 7, and 2 actually have nothing in common, which means I'm not going to be able to use greatest common factor to make this easier. So that's where I get into this new method. When you think about what you're multiplying, the coefficient on my x squared is going to come from the coefficients, if I had like this, something times x and something else times x. These two coefficients are where that 3 is coming from. So when I multiply the coefficient on this x and the coefficient on this x, I need to get 3. So what I'm looking for is I'm looking for the factors of 3. And luckily, the only way you can get 3 is 1 times 3. And then I also want to look at the factors of this 2. So just like I did before, I'm looking at the factors of my last term as well. 2, luckily, only comes from 1 times 2. This is where it gets a little tricky. What I have to do is I need to fill these in using these factors in this spot and these factors in this spot. But the problem is I don't necessarily know how they pair up. I don't know if it's 1x plus 1 times 3x plus 2, or if it's 1x plus 2 times 3x plus 1. And the only way that I can figure it out is to actually do the math and multiply everything out. So it's not necessarily challenging, it just takes a lot of time. So what I always do is I write out my first possibility, which would be x, that's like a 1x plus 1, and then I need to use my other factors, 3x plus 2. And what I'm going to do is I'm going to keep the coefficients the same, and I'm just going to change the constant. So my other possibility would be x plus 2 times 3x plus 1. So if you'll see what I did here, these are always the coefficients, or I'm sorry, the coefficients are always the factors of that a term, and the constants are the factors of the c term. And what I need to do is I need to multiply both of these out and see which one gives me that 7x in the middle. So hopefully you guys are okay with 1x being x, because that's just an added thing in there to make it more confusing. X times 3x is 3x squared. That's my first term. Outside would be 2x. Inside would be 3x. Last would be 2. 1 times 2 is 2. 2x and 3x make 5x, so that is not the correct factorization. So I try the next one. X times 3x is 3x squared. Outside is x times 1, which is x. Inside is 2 times 3x, which is 6x, and I can already see that 7x, so I'm good, but 2 times 1 is 2. So I get 3x squared plus 7x plus 2, which is what I was shooting for. So that tells me that the correct factorization of 3x squared plus 7x plus 2 is x plus 2 times 3x plus 1. So you're probably yelling at the screen right now like, what the heck did you just do? That's total nonsense, Mrs. Bergman. So let's do another one. Okay, so here's the second example that we're going to do using that method. And I actually just did this and then forgot about that negative sign. So something to pay attention to. Make sure that you're paying attention to positives and negatives, or else you'll do a whole bunch of work and then realize you didn't do it correctly. So for this guy, again, I'm going to look for a greatest common factor. 2, 7, negative 7, and 3 don't have anything in common except for 1. So I can't use greatest common factor to help me here. So what I need to do then is to look at the factors of 2, look at the factors of 3. When I do this, my middle term being negative means that I need to think about the factors of this 3. So this is a positive 3. So remember, that means either both factors are positive or both are negative. Because my middle term is negative, that means they both must be negative. So to skip ahead a little bit, the factors of 3 then must be negative 1 and negative 3. So the same rule applies from 7.7. If you have negative numbers back here, that's what you're going to do to deal with those. I also need to think about the factors of 2, which are 1 and 2. So luckily there's only one factor pair for each of these. That makes this quite a bit easier. So remember that these factors are going to be the coefficients for your x. These factors are going to be your constants inside those factor pairs. So for my first factor pair, let's use x, like 1 times x, which is x, minus 1, and then the 2 and the 3 would be 2x minus 3. So the first number is coming from the 1 and the 2, and then my constant is coming from this negative 1 and this negative 3. My other possibility is going to keep the variable terms the same and just switch the constants. So those are all of the possible combinations of these factors here, where these are your coefficient and these are your constant. And then again, like I did before, I have to multiply these out to figure out what my actual, which one of these is the actual factorization of 2x squared minus 7x plus 3. So x times 2x is 2x squared. X times negative 3 is negative 3x, or I'm subtracting that 3x. I have a 1 and a 2x for my inside, so minus 2x, and then negative 1 and negative 3 make a positive 3. Something that I want you to notice, when you do these, you should always get your A and your C as your first term and your last term, because that's how you picked these numbers, was to make sure that you were getting a 2 and a 3. So this darn well better be a 2x and a 3. So when you multiply these out, that should always happen. If it doesn't, you picked the wrong factors. You messed something up. You need to go back and start over. Just keep that in mind. Anyway, negative 3x, negative 2x make a negative 5x. So that's not the correct factorization, or this is not the correct factorization. So I need to try this one. X times 2x, better be 2x squared. Outside is a negative 1x, or negative x. Inside is 3 times 2, so negative 6x. And then negative 3 times negative 1, again, had better be a positive 3. That's what I'm shooting for. Then I see that I'm subtracting x and 6x, so together I'm subtracting 7x. 2x squared minus 7x plus 3. Oh look, 2x squared minus 7x plus 3. That's exactly what I wanted. Oops. So this right here is my factorization. Okay, let's try example 3, where it gets just a little bit trickier, because now, well, we have a negative last term, so we know that these factors, one is positive and one is negative, but we don't know which is which, and unfortunately we don't have a quick rule to decide based on that middle term anymore. We can't use the rule from 7-7, so we have to try both combinations. Also, if you think about the factors of 4, there's more than just one factor pair. So that makes it just, a touch trickier. So our factors of 4 are 1 and 4, or 2 and 2. Our factors of negative 5 would be 1 and negative 5, or negative 1 and positive 5. I'm going to write both of those out. And luckily, those are the only possible factors for negative 5. I have to sneeze. Excuse me. Anyway, so I have more combinations that I have to try. Now, because these 2's are the same, that actually cuts down on the possible options a little bit, but we're still going to have a couple more possibilities that we have to try. So first I'm going to start with an x, so 1x, and then actually I can do this. So that's the 1x and the 4x. Now I'm going to try a positive 1 coming from here and subtracting 5 coming from there. Now I need to flip the positive 1 and the negative 5. So it could be x minus 5 and 4x plus 1. So that right there tells me my combinations with the 1 and the 4 and the 1 and the negative 5. But then I need to try this again with the negative 1 and the positive 5. So I'm going to keep these the same, but now it could be x minus 1 times 4x plus 5, or x plus 5 times 4x minus 1. So I tried these combinations, I can try those combinations. And then I get to do it all over again, but now with 2's. So I could have 2x plus 1, but then my other factor is 2x minus 5. In this case, I don't have to do the switching because these are both 2's. So that does cut down just a little bit. So those are all my combinations of the 2 and the 2 and the 1 and the negative 5. Now I need to try the 2 and the 2 with the negative 1 and positive 5. So it could be 2x minus 1, 2x plus 5. So now you'll see we have 1, 2, 3, 4, 5, 6 factor pairs that we have to try to see which one works. So you can see why, if there's a greatest common factor, you definitely want to take that out first so you can avoid doing all of this work. Because now I have to do some multiplication. X times 4x, 4x squared. Outside is negative 5x. Hopefully you're getting really fast at FOILing. Positive 1 and a 4x make a positive 4x. And last is 1 and negative 5, so subtracting 5. That makes a negative 1. I want 8, so not this guy. X times 4x, 4x squared. Outside is positive x. Inside is negative 20x. And last is negative 5. That makes negative 19, so that can't be it. X and 4x make 4x squared. Outside is 5x. Inside is negative 4x. Last is negative 5. This is going to make a positive 1, which is still not that 8 that we're shooting for. So that one didn't work. X and 4x make 4x squared. Outside is negative x. Inside is plus 20x. I'm going to stop there. I can see that that's obviously not 8. Oops. So let's start with the 2x's. 2x and 2x make 4x squared. That's going to be 2 times 5 is 10, so negative 10x. Inside is a positive 2x. And last is negative 5. Negative 10 and positive 2 make negative 8, so nope, not what we want. Hopefully this one will work, or else we screwed something up. 2x squared and 2x, or I'm sorry, 2x and 2x, 4x squared. Outside is 10x. Inside is negative 2x, yay, minus 5. These make 8x together. So, the factorization of 4x squared plus 8x minus 5 is 2x minus 1 times 2x plus 5. So, you can see why the fewer factors of these two numbers there are, the easier these are. Because think about it, if that was like a 24, we would have so many possible things we'd have to try first. It can get ugly. But that is the general idea of what you're doing here. So the biggest idea here is that you're trying all of your possible combinations, and you have to actually multiply all of them out to decide what the biggest combination is, or what the correct combination is. So I'm not going to go through this entire thing, but I'm just going to show you one more example just to show you where those combinations come from. So the factors of 3 are 1 and 3. The factors of 8 are 1 and 8, or 2 and 4. Now you'll see my middle term is negative though. My last term is positive. So these all have to be negative to get a positive last term and a negative middle term. So I know that the coefficients on my x are always going to be 1 or 3. So it'll be an x and a 3x, like this. So the x can go with the negative 1, which means this 3 has to go with that negative 8. Or they could be flip-flopped, where it would be x and a negative 8 and a 3x and a negative 1. So those are the combinations of 1 and 3 with negative 1 and negative 8. But then we could also have this negative 2, negative 4 pair, where this x is paired up with the negative 2, which would leave the 3 and the negative 4 together. Or it could be x minus 4 times 3x minus 2. So I'm not going to go through and multiply all these out. I just wanted to show you one more example of flip-flopping the numbers here to get all of your combinations. If you want to multiply these out and figure out which one is correct, go for it. And I will tell you right now that this one is actually the correct answer. Now, you might see this written like this, 3x minus 2 times x minus 4. These are the exact same thing. So if you're going through the answers and you're like, oh, mine's close but not quite, these are actually the same. The coefficient and the constant, 3x minus 2, are paired up. right here, the coefficient 3 is paired up with a constant -2. So these are the exact same thing. These are the exact same thing. So that's really like doing A times B or B times A. So hopefully you'll see the difference, why you're allowed to switch the entire group of parentheses. We're not just switching something in the parentheses between these two. The entire grouping is flip-flopped. So just keep that in mind when you're checking your answers, that they just might be written a little bit differently than how you have it written. So if you have any questions about that, make sure you let us know. So your homework for tonight is on page 380. And it's numbers 1, 2, 6 through 28 even, 31 through 36, and 39 through 42. So that's your assignment for tonight. And you're almost done with this chapter. So you are doing awesome. Keep it up.